And now in this lecture we'll answer two questions. In the first question we find out the area of this circle, and in the second question we'll find out the area of trapezoid ABCD. So we'll start with the first question. In the drawing we have a circle, and from the current standpoint, point P, we have two tangents to this circle, tangent PA and tangent PB. And we also have the right triangle ACP that cuts the circle at 2 points. Point A and this point, we know that side CP of the right triangle ACP equals to 4 units in its length. This is length FBC that is equals to 1 unit in its length. And our mission is to find out the area of this circle. So first of all, we can implement here rule 2. If we focus on this common standpoint, point P, from this common standpoint, point P, we have two tangents to this circle, tangent PA and tangent PB. And according to rule 2, they are equal to each other. That is to say, PA equals to PB. So I write it down. According to rule 2, PA equals to PB. The length of tangent PA is equals to the length of tangent PB according to rule 2. But it is actually given us the question that PB in total equals to 4 plus 1, that is 5. So I write it down, PB equals to 5 units in its length according to what is given as the question. And from this equation, PA equals to PB equals to 5, we will derive that PA is also equals to 5 units in its length. And this is PA, that is equals to 5 units in its length. In the next step, I'll copy the right triangle ACP in a new page and we'll implement the Pythagoras theorem of this right triangle ACP. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Here by PT is the relation for Pythagoras theorem. So actually, this is the right triangle ACP that is going from the original drawing according to the Pythagoras theorem. In this right triangle ACP, AP squared, that is the square of the hypotenuse, equals to AC squared plus CP squared. So I write it down. So AP squared, that is the square of the hypotenuse, equals to AC squared plus CP squared. AP equals to 5, therefore AP squared is 5 squared, that is 25, and it is equals to AC squared. AC is the missing side, so we leave it as it is, so AC squared equals to AC squared plus CP squared. CP is 4, therefore CP squared is 4 squared, that is 16. So in total, if we found out that 25 equals to AC squared plus 16, here we subtract 16 from this equation, and finally get that AC squared equals to 25 minus 16, and 25 minus 16 is 9, so AC squared equals to 9. Here we take a root out of this equation, and finally get that AC equals to the square root of 9, that is 3. So AC equals to 4 units in its length. Okay, I know that this side AC equals to 3 units in its length. AC equals to 3. In the next step, we will define the center of this circle. This point is point O. And we will also define the radius of this circle as x. So in the next step, we will join points O and B together by straight line. Point O is the center of the circle, point B is the point of the circle itself, therefore OB is the radius of the circle, that is equals to x according to our definition. So here we can implement rule 1. Why? Because we have the radius OB that is drawn to point B, that is the point of tendency of tangent BB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent PB will be perpendicular to the radius BO. If PB is perpendicular to BO, it means that this angle equals to 90 degrees according to rule 1. It is given us the question that PA and PB are tangent to this circle. So PB is a tangent, it is absolutely a straight line. So if you focus on the upper side of the straight line PB at point C, here the sum of the angles must be equal to 180 degrees according to rule 3 that says that the sum of the angles on one side of a straight line is equal to 180 degrees. In this case, it means that the sum of the angles on the upper side of the straight line PB at point C, the sum of the angles must be equal to 180 degrees. So which angles we have at the upper side of PB at point C? We have this angle that is a right angle, plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees according to rule 3. Therefore, this missing angle must be equal to 90 degrees in its size. In the next step, we will do a construction, that is to say, from this point, point O, that is the center of the circle, we will draw perpendicular on AC. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We will define the touching point of the perpendicular from point O and AC. This point is point F. By doing this construction, we created quadrilateral OFCB. Inside quadrilateral OFCB, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle, in total they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this fourth missing angle must be equal to 90 degrees in its size. So inside quadrilateral OFCB, we have 4 right angles, and according to rule 5, any quadrilateral that has 4 right angles must be this right angle, if not a square. So we relate to quadrilateral OFCB is right angle because it has 4 right angles. So quadrilateral OFCB is right angle according to rule 5. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle OFCB, side OF must be equal to the opposite side CB. But CB is 1, therefore OF must be also equal to 1 unit in its length. Likewise, according to the same rule, in the same rectangle OFCB, side OB must be equal to the opposite side CF. But OB is x, therefore CF must be also equal to x units in its length. What is the length of the missing line segment AF? AF equals to AC minus FC. Again, AF equals to AC minus FC. So write it down. AF equals to AC minus FC. So AF equals to AC, that is 3, minus FC, that is x. So in total, AF equals to 3 minus x units in its length. Write it down. AF equals to AF equals to 3 minus x units in its length. In the next step, we will join points O and A together by a straight line. Point O is the center of the circle, point A is the point of the circle itself, therefore OA is the radius of the circle that is equal to x according to our definition. In the next step, I'll copy the right range triangle OAF in a new page and we'll implement the Pythagoras theorem of this right range triangle OAF. Here by PT is the version for Pythagoras theorem. So actually, this is the right triangle OAF that is going to the original drawing, the right range triangle OAF that is going to the original drawing. According to the Pythagoras theorem, in this right triangle OAF, OA squared, that is the square of the hypotenuse, equals to AF squared plus OF squared. So write it down. OA squared, that is the square of the hypotenuse, equals to AF squared plus OF squared. OA equals to x, therefore OA squared equals to x squared, and it equals to AF squared. AF is 3 minus x, therefore AF squared is 3 minus x squared. Plus OF squared. OF is 1, therefore OF squared is 1 squared, that is 1. So in total, we shall find out that x squared equals to 3 minus x squared plus 1. Here we'll open the brackets on this side of the equation and we get that x squared equals to 3 minus x squared. 3 minus x squared equals to 3 squared, that is 9, plus x squared minus 2 times 3 times x, that is minus 6x, plus 1. So here we have x squared on both sides of the equation, so x squared will get cancelled. After I cancelled x squared, on this side of the equation we left with nothing, that is to say 0. On the other side of the equation we have 9 plus 1, that is 10, minus 6x. So in total we found out the 0 equals to 10 minus 6x. Here we add 6x to this equation. And finally we get that 6x equals to 10. Here we divide this equation by 2, and finally we get that 6x over 2 is 3x, equals to 10 over 2 is 5. So in total we shall find out that 3x equals to 5. Here we divide this equation by 3, and finally we get that x equals to 5 over 3 units in its length. So we actually found out that the radius of this circle x equals to 5 over 3 units in its length. Our mission is to find out the area of this circle. The area of any circle equals to pi times the radius of the circle squared. The area of any circle equals to pi times the radius of the circle squared. So the area of our circle must be equal to pi. The radius of our circle is x. area of the square is x squared. So in total, we should find out that the area of our circle equals to pi x squared. So it is equals to pi, x is 5 over 3, therefore x squared will be equal to 5 over 3 squared. So in total, we should find out that the area of our circle equals to pi times 5 over 3 squared. So it is pi times 5 over 3 squared. 5 over 3 squared equals to 5 squared, that is 25, over 3 squared, that is 9. So in total, we should find out that the area of this circle equals to either 25 pi over 9 square units, or in terms of numbers, it is equals to 8.727 square units. Repeat again, we should find out that the area of this circle equals to either 25 pi over 9 square units, or in terms of numbers, the area of this circle equals to 8.727 square units. So finish with the first question. In the next step, I'll present to you the second question and we'll solve it. Our mission in the second question is to find out the area of this trapezoid ABCD. It is given us in the question that side AB equals to 16 units, side AD equals to 17 units, side BC equals to 25 units, and side DC of this trapezoid ABCD equals to 44 units in its length. Again, our mission is to find out the area of this trapezoid ABCD. The area of any trapezoid equals to the sum of its two parallel bases. In this case it is AB plus DC, because AB is parallel to DC, times the height, h, divided by 2. The height, h, must create 90 degrees with the two bases. So already known, and we found out that in total the area of trapezoid ABCD is equals to the sum of its two parallel bases, that is actually AB plus DC, times the height. The height is h divided by 2. Repeat again that the height h must create 90 degrees with the two bases AB and DC. So in order to find out the area of this trapezoid ABCD, we will do a construction. That is to say, from this point A, from this point A, we will do perpendicular on DC. So actually this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the construction. We'll define the touching point of the perpendicular from point A in DC. This point is point E. We'll define the length of side DE as x. We'll define the length of side AE as h. H is actually the height of trapezoid ABCD. Why h is the height of trapezoid ABCD? Because h creates 90 degrees with the base DC. Okay, so in the next step, I'll copy the right triangle ADE in a new page, and we'll implement the Pythagoras theorem of this right triangle ADE. Here by PT is the abbreviation for Pythagoras theorem. Actually, this is the right triangle AED that I go from the original drawing. According to the Pythagoras theorem, in this right triangle AED, AD squared, that is the square of the hypotenuse, equals to AE squared plus DE squared. So I'll write it down. AD squared, that is the square of the hypotenuse, equals to AE squared plus DE squared. The hypotenuse AD equals to 17 units in its length. Therefore, AD squared is 17 squared, that is 289. And it is equals to AE squared. AE is h, therefore AE squared is h squared. Plus DE squared. DE is x, therefore DE squared is x squared. So in total we shall find out that according to equation 1, h squared plus x squared equals to 289. In the next step, we will do another construction. That is to say, from this point B, we will draw perpendicular on DC. Again, from point B, we will draw perpendicular on DC. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We will define the touching point of the perpendicular from point B and DC. This point is point F. We know that side AB is parallel to side DC. So those two angles, they are both located between the parallel lines AB and DC. And for that reason, they are both defined as interior angles because they are located inside the parallel lines AB or DC. They are located between the parallel lines AB and DC. Therefore, they are defined as interior angles. And those two angles are also located from the right side of the straight line BF, and therefore they are also defined as one-sided. In total, those two angles are both defined as one-sided interior angles. And according to rule 16, the sum of two one-sided interior angles is equal to 180 degrees. I'll repeat quickly on rule 16. According to rule 16, the sum of one-sided interior angle is equal to 180 degrees. So here we have line A is parallel to line B, and this line I cuts the two parallel lines A and B. This way we created those two angles that are defined as interior angles, and there are also one-sided angles. And according to this rule, rule 16, the sum of those two interior and parallel interior angles and one-sided angles, and the sum of those two angles must be equal to 180 degrees. That is to say, angle 4 plus angle 5 equals to 180 degrees. Likewise, those two angles are also defined as one-sided interior angles, and the sum of one-sided interior angles is equal to 180 degrees according to this rule, rule 16. So angle 3 plus angle 6 equals to 180 degrees. So we can actually implement rule 16 in our drawing. Why put in our drawing? we have those two interior angles, those two angles that are defined as interior angles and one-sided angles. And according to rule 16, the sum of those two interior angles and one-sided angles, the sum of them is equal to 180 degrees. So this angle equals to 90 degrees on its side. This is angle ABF. So in total, the sum of those angles, is equal to 180 degrees. So I'll write it down. So actually, this is a right angle that associated is equal to 90 degrees in its size, plus this angle, the angle ABF, that is the missing angle. In total, the sum of those two angles must be equal to 180 degrees, according to rule 16. Okay, again, I should find out that 90 degrees plus the missing angle ABF, in total, they must be equal to 180 degrees according to rule 16. Here we subtract 90 degrees from this equation, and finally get that the missing angle ABF is equal to 180 degrees minus 90 degrees is 90 degrees. So I think this is the missing angle ABF, this is equal to 90 degrees in its size according to rule 16. Likewise, those two angles are also defined as one-sided interior angles. Now, interior angles because they are located between the parallel lines AB and DC, and one-sided angles because both of them are located on the left side of the straight line AE, and therefore defined as one-sided interior angles. And according to rule 16, the sum of those two one-sided interior angles, the sum of them is equal to 180 degrees. So this angle equals to 90 degrees, plus this angle that is angle BAE. In total, the sum of those angles it must be equal to 180 degrees according to rule 16. So I write it down. This angle equals to 90 degrees in its size, plus the missing angle that is actually angle BAE. In total, the sum of those two angles it must be equal to 180 degrees according to rule 16. So if it again, I can find out that 90 degrees plus the missing angle BAE, because of the fact that they are both defined as one-sided interior angles, the sum of them must be equal to 180 degrees according to rule 16. Here we subtract 90 degrees from this equation, and we will get that the missing angle BAE is equal to 180 degrees minus 90 degrees is 90 degrees. So this is the missing angle BAE that is equal to 90 degrees in its size according to rule 16. So actually found out that inside quadrilateral ABFE we have 4 right angles. And according to rule 5, any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So we will relate to quadrilateral ABFE as a rectangle because it has 4 right angles. So I write it down. This quadrilateral ABEF is a rectangle according to rule 5. But we also know that the opposite sides of the rectangle are equal to each other. So in rectangle ABFE, side AB must be equal to the opposite side FE. But AB is 16, therefore FE must be also equal to 16 units in its length. Likewise, according to the sum rule, in the same rectangle ABFE, side AE must be equal to the opposite side FB. But AE is 8, therefore FB must be also equal to 8 units in its length. What is the length of the missing line 7 FC? The length of the missing line 7 FC is equal to DC minus DE minus EF. Again, FC equals to DC minus DE minus EF. So I'll write it down. FC equals to DC minus DE minus EF. So total FC equals to DC, that is 44, minus DE, that is X, minus EF, that is 16. So total FC equals to 44 minus X minus 16. 44 minus 16 is 28, so in total this expression equals to 28 minus X. So in total we should found out that FC equals to 28 minus X units in its name. FC equals to 28 minus X units. So in the next step, I'll copy the right triangle BFC in the new page, and we will implement the Pythagoras theorem with this right triangle BFC. Here by PT is a proportion for Pythagoras theorem. So actually, this is the right triangle BFC that I code from the original domain. According to the Pythagoras theorem, in this right triangle BFC, BC squared, that is the square of the hypotenuse, equals to BF squared plus FC squared. So I write it down. BC squared, that is the square of the hypotenuse, equals to BF squared plus FC squared. BC is 25, therefore BC squared is 25 squared, that is 625. And it is equals to BF squared. BF is 8, therefore BF squared is 8 squared plus FC squared. FC is 28 minus X, therefore FC squared is 28 minus X squared. So in total, if we found out that according to equation 2, 625 equals to 8 squared plus 28 minus X squared. Anyway, we'll open the brackets on this side of the equation 2, and we find out that according to equation 2, we have 625 equals to 8 squared plus 28 minus X squared. 28 minus X squared equals to 28 squared, that is 874 plus X squared minus 2 times 28 times X is minus 56X. So here we subtract 625 from this equation. After we subtract 625 in the side of the equation 2 we left with nothing, that is to say 0. On the other side of the equation we have x squared plus x squared minus 56x, and 874 or 625 equals to 159. So total, actually according to equation 2, we found out that 0 equals to x squared plus x squared minus 56x plus 159. But according to equation 1, we have already found out that x squared plus x squared equals to 289. So we can substitute x squared plus x squared in this equation 2 by 289 from equation 1. We'll do it now and we get that according to this equation 2, 0 equals to h squared plus x squared is 289 according to equation 1, minus 56x plus 159. Here we'll add 56x to this equation and finally get that according to equation 2, 56x equals to 289 plus 159 equals to 448. So in total, we should find out that 56x equals to 448. Here we divide this equation 2 by 56, and finally we get that x equals to 448 over 56 is 8. So x equals to 8 units in its length. And according to equation 1, we already found out that according to equation 1, h squared plus x squared equals to 289. And we also right now found out that x equals to 8. If x equals to 8, it means that x squared equals to h squared, it is 64. Therefore, we can substitute x squared in this equation 1 by 64. We do it now, and we get that according to this equation 1, h squared plus x squared, that is 64, equals to 289. Here we'll subtract 64 from this equation, and finally get that according to this equation 1, h squared equals to 289 minus 64 is 225. So total we found out that h squared equals to 225. Here we take a root out of this equation and finally get that according to this equation 1, h equals to the square root of 25, that is 15. So h equals to 15 units in its length. So we found out that the height, age of this trapezoid ABCD is equals to 15 units in its length. Our mission is to find out the area of this trapezoid ABCD. As I mentioned before, the area of this trapezoid ABCD equals to the sum of its two parallel bases, that is AB plus DC, times the height, that is H, over 2. So already known. The area of trapezoid ABCD, that is the area that we are looking for in this question, is equals to the sum of its two parallel bases, that is actually AB plus DC, times the height, that is H, over 2. So the area of trapezoid ABCD equals to AB, that is 16, plus C, that is 44, times H, that is 15, divided by 2. 16 plus 44 equals to 60, times 15 divided by 2. 60 over 2 is 30. In total, this expression equals to 30 times 15. 30 times 15 is 450. So today we found out that the area of trapezoid ABCD is equals to 450 square meters. And that is the answer to the question. And again, we found out that the area of this trapezoid ABCD equals to 450 square meters. So in the next step, we will summarize the lecture. We will start with the first question, of course. Our mission in the first question is to find out the area of this circle. So in the drawing we have a circle, and we have from the common standpoint point P, this coming from point P, we have two tangents to this circle, tangent PA and tangent PB. In addition, we have also the right angle ACP that cuts the circle at 2 points, A and this point. This is again ACP that is equals to 90 degrees inside. Side CP of the right angle ACP equals to 4 units in its length. This is side BC that is equals to 1 unit in its length. Again, our mission is to find out the area of the circle. So first of all, implement the rule 2. You can implement rule 2. If you focus on the common standpoint point P, from this common standpoint point P, we have two tangents to the circle, tangent PA and tangent PB. And according to rule 2, they are equal to each other. That is to say, PA equals to PB. So we repeat again. As we found out that according to rule 2, PA equals to PB. But it is given us the question that PB in total equals to 4 plus 1, that is 5. So PB equals to 5. So can I do that PB equals to 5? PB equals to 5. And from this equation PA equals to PB equals to 5, we will derive that PA also equals to 5 units in its length. So actually, this is side PA that is equals to 5 units in its length. In the next step, I'll copy the right angle ACP in a new plate and we implement the Pythagoras theorem on this right angle triangle ACP. According to the Pythagoras theorem, in any right angle, the square of the hypotenuse equals to the sum of the sides of the perpendiculars. This is right angle ACP that are coming from the original drawing. According to the Pythagoras theorem, in this right angle ACP, AP square, that is the square of the hypotenuse, equals to AC square plus CP square. AP is 5, therefore AP square is 5 squared, that is 25, and it is equals to AC square. AC is the missing sign, so we leave it as it is, plus CP square. CP is 4, therefore CP square is 4 squared, it is 16. So in total, we found out that 25 equals to AC square plus 16. Here we subtract 16 from this equation, and we found out that AC square equals to 25 from 16, that is 9. So AC square equals to 9. Here we took out of this equation, and we found out that the missing sign AC equals to the square root of 9, that is 3. This is 9 7 AC, that is equals to 3 units in itself. Here AC equals to 3. In the next step, we define the center of this circle, this point as point O. And we also define the radius of this circle as x. Then we join points O and B together by a straight line. Point O is the center of the circle, point B is the point of the circle itself. Therefore, OB is the radius of the circle that is equal to x according to our definition. It is given us the question that PB is a tangent. PB is a tangent, it is absolutely a straight line. So if we focus on the upper side of the straight line PB at point C, here the sum of the angles must be equal to 180 degrees according to rule 3 that says that the sum of the angles on one side of a straight line is equal to 180 degrees. In this case, it means that the sum of the angles on the upper side of the straight line PB at point C must be equal to 180 degrees. So which angles we have at the upper side of PB at point C? We have this angle that is the right angle, plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees according to rule 3. Therefore, this missing angle must be equal to 90 degrees in its size. In the next step, we did the construction, that is to say, from this point O, that is the center of the circle, we draw perpendicular on AC. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. When we did this construction, we can do quadrilateral OFCB. Inside quadrilateral OFCB, we have 1, 2, 3 angles. The sum of 3 angles is 270 degrees, so 270 degrees plus the size of this 4 missing angle. In total, it must be equal to 360 degrees according to the rule that says that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this 4 missing angle must be equal to 90 degrees in its size. So inside quadrilateral OFCB, we have 4 right angles. And according to rule 5, any quadrilateral that has 4 right angles must be this right angle plus a square. So we relate to quadrilateral OFCB is right angle because it has 4 right angles. Here, quadrilateral OFCB is right angle according to rule 5. But we also know that the opposite sides of a right angle are equal to each other. So an right angle OFCB, side OF must be equal to the opposite side CB. But OF is 1, therefore CB must be also equal to 1. Likewise, according to the same rule, in the same right angle OFCB, side OB must be equal to the opposite side FC. but OB is x, therefore FC must be also equal to x units in itself. What is the length of the missing line segment AF? From the drawing, it is very easy to see that AF in total equals to AC minus FC. Again, AF equals to AC minus FC. So AF equals to AC, that is 3, minus FC, that is x. So in total, AF equals to 3 minus x. In the next step, we join points O and A together by side line. OA is of course the radius of this circle, that is equals to x. In the next step, I copy the right grand triangle OAF in the new page and we implemented the Pythagoras theorem on this right grand triangle OAF. Okay, this is the right grand triangle that I call it from the original domain according to the Pythagoras theorem. This right triangle OAF, OA squared, that is the square of the hypotenuse, equals to OAF squared plus FO squared. Again, OA squared equals to OAF squared plus OF squared. OA is x, therefore OA squared is x squared, and it is equal to AF squared. AF is 3 minus x, therefore AF squared is 3 minus x squared, plus FO squared. FO is 1, therefore FO squared is 1 squared. So in total, we should find out that x squared equals to 3 minus x squared plus 1. So here we open the brackets of this expression, and we can find out that x squared equals to 3 minus x squared equals to 3 squared, that is 9, plus x squared plus 2 times 3 times x, that is minus 6x plus 1. So here we have x squared on both sides of the equation, so x squared will get cancelled. After we get x squared on this side of the equation, we have with nothing, that is to say 0, equals to, on the other side of the equation, we have 9 plus 1, that is 10, minus 6x. So in total, we shall find out that 0 equals to 10 minus 6x. Here we added 6x to this equation, and finally found out that 6x equals to 10. Here we divided this equation by 2. 6x over 2 is 3x, and 10 over 2 is 5. So in total, we shall find out that 3x equals to 5. Here we divided this equation by 3, and finally found out that x equals to 5 over 3 units in its length. That is to say, the radius of this circle x equals to 5 over 3 units in its length. Our mission is to find out the area of this circle. The area of any circle equals to pi times the radius of the circle squared. In the end, the area of any circle equals to pi times the radius of the circle squared. The radius of our circle is x, therefore the area of our circle must be equal to pi x squared. But x equals to 5 over 3, therefore x squared must be equal to 5 over 3 squared. So in total, the area of this circle must be equal to pi times 5 over 3 squared. So it is pi, and 5 over 3 squared is 5 squared, that is 25 over 3 squared, that is 9. So in total, we shall find out that the area of this circle equals to either 25 pi over 9 square units, so in terms of numbers, the area of this circle equals to 8.727 square units. We finished with the first question. In the next step, I actually presented to the second question, and we solved it. Our mission in the second question is to find out the area of this trapezoid ABCD. It is given us the question that AB equals to 16, AD equals to 17, side BC equals to 25, and side DC equals to 44 units in its length. Again, our mission is to find out the area of this trapezoid ABCD. Actually, the area of any trapezoid equals to the sum of its two parallel bases times the height divided by 2. Therefore, the area of our trapezoid ABCD must be equal to AB plus DC, because AB is parallel to DC. So it is AB plus DC times the height, that is h over 2. And repeat again, the area of our trapezoid ABCD must be equal to the sum of the two parallel bases, that is actually AB plus DC times the height, that is h, divided by 2. The height must create 90 degrees. We have to do bases AB and DC. In the next step, we did a construction, that is to say, from this point A, we draw perpendicular on DC. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the tangent point of the perpendicular from point A in DC. This point is point E. Then we define the length of side D as x, and the length of side AE as h. H is also the height of trapezoid ABCD. Why? Because h creates 90 degrees in the base DC. The next step we'll copy the right triangle AD in the new page and we implemented the Pythagoras theorem in this right triangle, triangle AD. Actually, this is the right triangle AD that are coming from the original drawing. Only to the Pythagoras theorem, this right triangle AD. AD squared, that is the square of the hypotenuse, equals to AE squared plus DE squared. Again, AD squared equals to AE squared plus DE squared. AD is 17, therefore AD squared is 17 squared, that is 289. And it is equals to AE squared. AE is 8, therefore AE squared is 8 squared plus DE squared. DE is x, therefore DE squared is x squared. So in total, we found out that according to equation 1, 289 equals to x squared plus x squared. In the next step, we did another construction, that is to say, from this point B, we go perpendicular on DC. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point B and DC. This point is point F. Now, we know that AB is parallel to DC. So those two angles are located between the parallel lines AB and DC, and therefore they are defined as interior angles. Those two angles are also located in the right side of the straight line AE, and therefore they are both defined as one-sided. So in total, those two angles are defined one-sided interior angles. And according to Rule 16, the sum of two one-sided interior angles is equal to 180 degrees. Therefore, the sum of those two angles must be equal to 180 degrees according to Rule 16. This angle equals to 90 degrees. This is the missing angle ABAE. So in total, the sum of those two angles must be equal to 180 degrees according to Rule 16. So 90 degrees plus the missing angle A 90 degrees plus the missing angle BAE, in total they must be equal to 180 degrees. Here we subtract the 90 degrees from this equation and finally found out that the missing angle BAE must be equal to 180 degrees minus 90 degrees, that is 90 degrees. So this is the missing angle BAE, that is equal to 90 degrees in size. Likewise, according to the same rule 16, because of the fact that those two angles are defined as interior angles and one-sided angles, and according to Rule 16, the sum of those two angles must be equal to 180 degrees. This angle equals to 90 degrees, plus the missing angle ABF, in total they must be equal to 180 degrees according to Rule 16. I repeat again, 90 degrees plus the missing angle ABF must be equal to 180 degrees according to Rule 16. Here we subtract the 90 degrees from this equation and find out that the missing angle ABF equals to 180 degrees minus 90 degrees, that is 90 degrees. So this is the missing angle ABF, that is equal to 90 degrees in size. So actually, we can do here inside quadrilateral OABFE, inside this quadrilateral ABFE, we have 4 right angles. And according to Rule 5, any quadrilateral that has 4 right angles must be in this rectangle if not a square. So we relate to quadrilateral ABFE is a rectangle because it has 4 right angles. Here, quadrilateral ABFE is a rectangle according to Rule 5. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle ABFE, side AB must be equal to the opposite side FE. But AB is 16, therefore FE must be also equal to 16. Likewise, according to the same rule, in the same rectangle ABFE, side BF must be equal to the opposite side AE. But BF equals to 8, therefore AE must be also equal to 8. What is the length? Actually here, A equals to 8, therefore BF must be also equal to 8. So what is the length of the missing 970 FC? FC equals to DC minus DE minus EF. Again, FC equals to DC minus DE minus EF. Repeat again. FC equals to DC minus DE minus EF. So FC equals to DC, that is 44, minus DE, that is X, minus FE, that is 16. So in total, FC equals to 44 minus X minus 16. So FC equals to 44 minus 16, that is 28. So in total, this expression equals to 28 minus X. So in conclusion, we should find out that FC equals to 28 minus X units in itself. The next step, copy the right triangle BFC in your page and implemented the Pythagoras theorem. This right triangle BFC. So see, this is right triangle BFC that they copied from the original domain according to the Pythagoras theorem. This right triangle BFC, BC squared, that is the square of the hypotenuse, equals to BF squared plus FC squared. BC is 25, therefore BC squared is 25 squared, that is 625, and it is equals to BF squared. BF is S, therefore BF squared is S squared, plus FC squared. FC is 28.6, therefore FC squared is 28.6 squared. So in total, according to equation 2, I should have found out that 625 equals to S squared plus 28.6 squared. Here, open the brackets of this equation, and according to this equation 2, I should have found out that 625 equals to 8 squared plus 28.6 squared. 28.6 squared equals to 28 squared, that is 834, plus x squared minus 2 times 28 minus x, that is minus 56x. Here we subtracted 625 from this equation 2. After we subtracted 625, in this side of the equation we have nothing, that is to say 0. On the other side of the equation we have x squared plus x squared minus 56x. 874 minus 625 equals to 159. So in total, according to equation 2, I should have found out that 0 equals to x squared plus x squared minus 56x plus 159. We already found out that according to equation 1, x squared plus x squared equals to 289. Therefore, we can substitute x squared plus x squared in this equation 2 by 289. We did it, and we found out that according to this equation 2, 0 equals to x squared plus x squared, that is 289 according to equation 1, minus 56x plus 159. Here we subtracted, we added 56x to this equation, and finally found out that 0 plus 56x is 56x equals to 289 plus 159 equals to 448. So in total we should found out that 56x equals to 448. Here we divided this equation 2 by 56 and finally found out that x equals to 448 over 56. 448 over 56 equals to 8. So in conclusion, we found out that x equals to 8 units in its length. According to equation 1, x squared plus x squared equals to 289. We just right now found out that x equals to 8. If x equals to 8, it means that x squared must be equal to x squared to squared, that is 64. Therefore, we can substitute x squared in this equation 1 by 64. We did it, and we found out that according to this equation 1, x squared plus x squared, that is 64, equals to 289. So x squared plus 64 equals to 289. Here we subtracted 64 from this equation and finally found out that x squared equals to 289 minus 64 equals to 225. So in total we found out that according to equation 1, x squared equals to 225. Here we took out of this equation and finally found out that h equals to the square root of 225, that is 15. So we found out that the height edge of this trapezoid ABCD equals to 15 units in its length. Our mission to find out the area of this trapezoid ABCD. The area of trapezoid ABCD equals to the sum of its two parallel bases, that is AB plus DC, times the height, that is h over 2. Okay, again, the area of trapezoid ABCD equals to the sum of its two parallel bases, that is AB plus DC, times the height, that is h over 2. AB is 16, DC is 44, h is 15, divided by 2. 16 plus 44 is 60, so it is 60 times 15 over 2. 60 over 2 is 30, so in total this expression equals to 30 times 15. 30 times 15 is 450. So in conclusion, we found out that the area of this trapezoid ABCD equals to 450 square units. Okay, thank you very much.